Hi there and welcome to another video from Hegarty Maths. It's our fifth video on factorising quadratic expressions. We're going to try and factorise quadratics where we have a negative coefficient in front of x squared. Just to start with, a couple of things that's going to be useful in this video. Pause the video and evaluate the following product. Well, hopefully because you know multiplication is commutative and associative, you would have probably said, right, I'm going to do 2 multiplied by 5 first, which is 10, and then I'm going to do the 10 times the 18 that I didn't touch yet, and I'm going to get 180. Now I just want to point out a mistake students sometimes think. They think that they sometimes don't realize you can do that, and they think maybe you double the 18 and double the 5 and times them together. So they think when they see 2 times 18 times 5, they do 2 times 18, which is 36, and 2 times 5, which is 10, and they multiply those out and get 360. And you can see that they've totally got the wrong answer there. That really is not correct at all. You only need to multiply one of the numbers by 2, and you've done that multiplied by 2. That's the way multiplication works. That's going to be dead useful in the video coming up. Next thing to talk about, you've previously factorised an expression like this. Pause the video and double check you can do that. Well, I would want you to start off by looking at the 2, the 10 and the 12, and I would like you to think, is there a common factor in 2, positive 10 and positive 12? Well, there is indeed. There's a common factor of 2, which as a step 1 you can factorise out. What would you get here? Well, hopefully you realise you'd get x squared, add 5x, add 6. Because 2 times x squared is 2x squared, 2 times positive 5x is positive 10x, 2 times positive 6 is positive 12. And then we should do one more step and actually factorise this quadratic expression. So keep the 2 where it is, and you're thinking of two numbers that multiply to positive 6 and add to positive 5, and hopefully you realise that's x add 2, x add 3. And we've done a whole skill on that already, so go back there if you're not sure about this. Now, what we're going to do in this video is factorise things like as follows. Now, if you want to pause the video and have a think how to do that before I show you, you're more than welcome. But what I might do is I'll look at that and say, well, there's a negative 1x squared, there's negative 5, there's negative 6. Maybe as a step 1, kind of like how I factorised out a 2 up above, what if I factorise out a negative 1? Then in the brackets I would get x squared, add 5x, add 6. Why? Well, negative 1 times positive x squared is negative 1x squared, negative 1 times positive 5x is negative 5x, negative 1 times positive 6 is negative 6. So factorising out that negative 1 makes anything that was negative go positive. In the same token, anything that was positive will go negative. Now we're in a great position, we can actually factorise this like we did above. And so we have negative 1, and it would factorise to x add 2, x add 3. And there you go, we've factorised that expression there, which is really useful for us. So that's the type of thing we're going to be doing here. We're going to be factorising out a negative number, then factorising the quadratic expression that's left. Let's have a go at some examples. Pause the video and have a go at this one if you think you can. Right, I know there's negative 1x squared, negative 9, negative 20, so I'd factorise out a negative 1 as my first step. Inside the brackets, anything that's negative now becomes positive, so I just get x squared, add 9x, add 20. Now I'd factorise the expression inside the brackets. I'm looking for two numbers that multiply to positive 20 and add up to positive 9. That's easy. Positive 4 and positive 5 do the trick. Keep the negative 1 there. It'll be x add 4, x add 5. Done. We've done that question. Next one. Pause the video and have a go at this one. Slightly different. I wonder if you can see how. Well, again, I've got a negative amount of x squared, so a good idea would be to factorise out negative 1. Anything that was negative becomes positive. Anything that's positive now becomes negative. So what goes inside? Well, it would be x squared, subtract 9x, add 20. Let's just think about why that works. Negative 1 multiplied by x squared is negative 1x squared. Negative 1 multiplied by negative 9x gives me the positive 9x. Negative 1 multiplied by positive 20 gives me negative 20. Now I'm going to factorise this quadratic expression here, keeping the negative 1 there. I'm looking for two numbers that multiply to positive 20 and add to negative 9. They're going to be x subtract 4, x subtract 5. Now, this is where there's one extra little layer of complexity here. When we have a case like this, where there's a -1 on the outside, and there's two brackets here where maybe there's some negatives in them, like -4 and -5, we're allowed to multiply the -1 into one of the brackets. Do you remember, just like when we had 2 times 18 times 5, I could do the 2 times the 5 if I wanted first and then times 18. Or if I really wanted, I could have done the 2 times the 18 and then times by 5. So in textbooks, I'm just pointing this out to you, sometimes because mathematicians don't like writing the negative, they will put the negative or multiply the negative back into one of the brackets. Just one, remember, because in the same way here, you don't double both, you just double one. Now, you could put them back into either bracket you want. If you put it into this bracket, and something negative now becomes positive, the positive things now become negative, this bracket would become 4 subtract x, and this second bracket would stay the same. Or, guys, you could have put it into the second bracket if you wanted. The first bracket would have stayed the same. The second bracket, the signs would have changed. And that's how you may see it written in as answers in textbook or exams. So I'm just pointing out to you for that very reason. Now, we didn't do it in this case here, just to point out, because that was positive and that was positive, so the signs would both go negative and it would just look messy. The reason we did it here is one of these was a negative, that was, and in fact that was as well, and it would just look neat to put the negative in there because the negative thing will become positive and the positive thing becomes negative. That just looks kind of neat. So that's why we do it in these cases. One thing to point out to you, maybe you won't see it written like that in an exam. Because it's -x², you may see that written second term or third term. You may see it written with the positive first, positive 9x, take away x², take away 20. But just know these two things mean the same. Right, let's try another one with this little trick I told you how to finish it off. Pause the video, have a go at this. Step 1, factorise out -1. Inside we'd get x² add 9x subtract 22. Now you've got to think to yourself, right, keep that -1 there for now. Two numbers that multiply to -22 and add up to +9. Well, I think I've got them. I think that's x add 11 and I think that's x subtract 2. Because +11 multiplied by -2, -22, +11 add -2 is +9. Now, which one would you multiply this -1 into, if any? Well, don't put it in that one, guys. They're both positive. That would just look messy. It would be -x subtract 11. No need to put it in there. You'd usually see it putting in there because it would make that -2 +2. It would make that +x -x. So you would probably see it written in an answer book. You'd see the x add 11 staying as it is, but this one you'd see written as 2 subtract x. Okay? And last thing to point out, again, you may see it written like that. The 22 written first because it's the positive, take away x², take away 9x. Pause the video and have a go at these two final ones to check you totally understand this. Right, step 1, because I've got -x², I'm going to factorise out a -1. Anything negative now becomes positive, anything positive now becomes negative. I get x² add x, take away 2. Now, let's try and factorise this quadratic expression. Two numbers that multiply to -2 and add up to +1. I make that x add 2, x subtract 1. Where would you put the -1 back into? Would you multiply any of the brackets by it? Well, certainly not the first one, but I'd multiply the second bracket by the -1, and I'd get myself x add 2, that stays the same. The positive x becomes -x, the -1 becomes +1, we get 1 subtract x, like that, and we're done. And this one here, same old stuff, factorising out a -1, we'd get x² there. Now do notice the x² is not the first term here, so I purposely picked that, and I'm then rewriting them with the x² first. I'm writing them x², then x's, then numbers, just because that's how quadratics are normally written. So if I take out the -1, I'll have positive x². This positive 10x will become negative 10x, and this negative 16 will become positive 16. Then I'm going to factorise that quadratic expression there. Two numbers that multiply to positive 16 add to negative 10. That's going to be x subtract 2, x subtract 8. And then where would I multiply the negative back into? Well, I could do it into either one. That would tidy up nicely, or that would tidy up nicely, but not to both. So the answers in this case would either be 2 subtract x and then keep the x subtract 8 as it is, or you could have yourself x subtract 2, 8 subtract x. And to be totally honest with you, it would even be fine to leave your answer like this with -1 in the front. It's just you'll see it tidied up in exam mark schemes and textbooks as follows. And that's it for this video. Thanks loads for